Welcome back to the Navigation Bootcamp by Peter van Geit at ultrajourneys.org. In previous chapters, we learned about various available map sources which contain different types of terrain details, which will help us in planning our remote exploration journeys of the Himalayas and other mountain ranges. We learned about satellite maps, which are specifically useful, giving a high resolution visual imagery, allowing us to spot remote villages and small trails in the mountains, as well as vegetation density. In topographic maps, the previous chapter, we learned about contour lines and understanding the topography of the terrain, which is extremely useful while planning trails, routes through the mountains, allowing us to identify key terrain details like ridges, valleys, saddles and peaks, as well as basically the steepness of the terrain. In this chapter, now we're going to learn about available digital elevation models, which can be downloaded online. From these, we will be able to extract contour lines and overlay these on various maps. We'll be focusing on one specific region here called Nagalapuram, a small mountain range north of Chennai. Here we look at this mountain range in 3D visual view in Google Earth. So I'll show you how to identify the digital elevation model data for this specific region of the planet, how to generate contour lines, and how to overlay those contour lines over the specific region, adding a lot of valuable information on the steepness of the terrain and assisting you in identifying ridges, valleys, peaks to help you in planning your journeys through this mountain range. Digital elevation model data and contour lines will also be very useful to be used in addition with Survey of India maps, especially for the Himalayas. Many of the Survey of India maps have a lot of useful details at a very high scale of 1/50K, available for download either online or in paper version from the Survey of India offices in the various states. Unfortunately, for the Himalayas, Jammu and Kashmir, Himachal, Uttarakhand, many of those maps will not have contour lines. So being able to generate contours and overlaying those contours on these maps will again make these maps so much more valuable in your Himalayan exploration journeys, basically. Okay, let's get started now. So we'll start basically, like in the previous chapter, we'll first download from the Survey of India map the corresponding map, D44 and 14, for this specific region. So you'll have to log in here with your other core details and download this specific map tile. So I've already done this. Once downloaded, you can open the same in Google Earth by adding an image overlay. So you can open the downloaded map here, voila. And you can directly georeference the map by specifying the latitude and the longitude boundaries. In this case, we talk about 79.75 degrees eastern longitudes, which is the left boundary, till 80 degrees east for the east boundary. Same with southern boundary of 13.5 latitude till 13.75 latitude on the northern boundary. So basically 15 by 15 minutes area corresponding to around 28 by 28 kilometers. So here we have now imported this georeference, the map, Survey of India map for the northern section of Nagalapuram. And we'll be generating contour lines over this same map. To generate contours, before we do that, let's learn a little basics about digital elevation models. In the year 2000, the NASA launched the SRTM mission, the Shuttle Radio Topography Mission, which was the first effort to generate a digital elevation model of the planet, covering from this latitude to this latitude, so not including the south and the eastern latitudes, the southern and northern, sorry, covering almost 80% of the planet. Later on, more efforts were done by different countries, including India. First elevation models were released in 2009, available for download, typically in tiles. Every tile is 1 degree latitude by 1 degree longitude. So every tile will be named according to the, in this case, north 45 degrees latitude, east 6 degrees longitude, corresponding to the southwest corner of the tile, which is 1 degree again horizontal and 1 degree spans vertical. The resolution of this data corresponds to 1 arcsecond, as we saw in a previous chapter on latitude, longitudes, and global positioning system. 1 arcsecond corresponds to 30-meter precision, which will be fairly accurate to generate our contour lines. Similarly, also in more recent years, India has generated digital elevation models of the planets using their Cartosats Earth observation satellites. We have several generations here, primary use, I guess, for military purposes and secondary for civilian purposes. Data generated by Cartosat 1 in 2015, I believe, is available for download on the Bhuvan website at this URL. So I'll share all these URLs in the assignments. On this website, you get an image of India and you can mark the region that you're interested in. So you'll have to select Cartosat 1. You can select the latest version 3. And so this again, as we mentioned earlier, is available in 1 by 1 second tiles. In this case, we zoom in onto the specific tile here, so which includes a large part of Venkataswara National Reserve Forest, Andhra, part of Karnataka, the Deccan Plateau here basically, as well as Nagalapuram, which is shown here. So I'm gonna select the tile by just visually clicking on the one I want. Voila, that's it, stop. And then basically next, I will be able to download this, the elevation data generated by Bhuvan for this specific arc degree. In this case, I've already, I mean, you will need to log in. You can easily create an account and log in. On this website, you'll have to do that before you can download. I've already done the same. After downloading, you'll need one tool called Cubies. Cubies is available for free download online. It's an open source project that has a lot of useful GIS features, one of them being the ability to read elevation data and generate contour lines. So after downloading this, you can just select a new project. You can add a new layer. In this case, we'll add a raster layer. We can then download the digital elevation data downloaded from Cartosat. After unzipping the file, you will get a TIFF file which contains all this elevation data with 1 arcsecond precision. You can open it, and for this 1 degree by 1 degree, so around, I guess, 20 by 28 kilometers, we'll get the elevation data. Now let's generate contour lines for this specific region here. To mark this region, we'll have to go to extraction, clip raster by extent. So basically in clipping extent, select an extent on the canvas. We are just gonna clip this specific region, voila, run in the background. So this is gonna add this element here separately. And selecting this one, we are now gonna generate, again, extract basically contour lines, which will be useful in KMZ format, which can be imported in Google Earth and overlaid on a variety of maps. In this case, I'm just gonna generate 10 meters contour lines. So every increase of altitude of elevation of 10 meters is, we are gonna generate a contour line from this elevation data. So this again can be run in the background, and bang is gonna generate contour lines with 10 meters altitude precision for this range. After doing this, we can then right-click, export this in a KMZ format, a keyhole markup language, which we learned in previous chapters. give it a useful name. Let me save this in a known directory, downloads, perfect. And give it a name, Nagala contours 10 meters. Voila, there we go. Okay. Permission denied. I think let's try again. It's probably something related to the directory. So let's save it in downloads. And let's call it Nagala contours 10 meters. Yeah, probably the name already exists. So I'll just call it 2. Okay, there we go. Voila. This will generate a KML file, which can then be overlaid, opened in Google Earth and overlaid on top of this survey of India map, which is lacking the contour lines. So we can open this file here. Voila, the one we generated. And Google Earth is simply gonna overlay this now on top of our survey of India map. So after doing this, we can add both the survey of India map in a separate folder. So let us add maybe a folder, my SOI map with contours. Voila. So where we can add the both the survey of India map and the contour lines of 10-meter precision in a single folder. There we go. After doing this, both will be saved in this specific folder. We can enable both the layers individually or separately. So we can save this now as a KMZ file. So Nagala survey of India and contours 10 meters. Save this one. And this will now be a self-sufficient package KMZ file containing both the contour lines as well as the JPEG image georeferenced survey of India map, which can then be downloaded in your phone. And after doing so, you can basically, voila, open it in Google Earth, and you can basically use the survey of India maps and the contour maps to navigate using your phone and using Google Earth Mobile, which reads this KMZ file to mountain ranges. I also have a map here generated for the Himalayas. This is the Lingti Valley, which has survey of India map, has a lot of useful details there and trails through this valley. Again, combined with these 10-meter contour lines, gives you all you need to basically explore these new mountain ranges. Voila, that's it. So what I want you to do now is basically repeat the same as what you saw in this module. You will have to download this survey of India map. You'll have to download the contour lines from the Bhuvan site, download Cubies, then basically open the global digital elevation model, generate contours, export it as a KMZ, overlay it on Google Earth, and then basically save it as a KMZ and send it to your phone, where you can open it in Google Earth Mobile and use it for navigation. Basically, to show that you have completed this assignment, I basically want you to show me a screenshot of survey of India map of Nagalapuram, along with the contour lines. So you just generate a screenshot of this to prove that you have completed the assignment. Here you go. You will upload this in a public Google album and then submit the Google album link on ultrajourneys.org in the respective chapter where I will review the assignment and give you feedback.